So, welcome everybody. And today we are going to be doing like a getting started with Hevo demo days. This is a series that we are going to be doing on different themes every 15 days. So, today we just wanted to give a basic idea of what Hevo is, what the capabilities are, and how can we help you in your data integration journey. With us, we have Arav. Arav has been in this company for a couple of years. He is the best person to know about Hevo when it comes to any technical aspect of it. So, thank you so much, Arav, for joining us today. And for the agenda today, we will be just having a quick overlook at what we have to why do we need to focus on why Hevo is important, or why any data integration is important. And then we'll go into a quick demo, so it'll just take you like a 15-20 minute to create a pipeline. So we'll be going into the depth of it, and then we'll go on to the real time case study. Arav, I think over to you, and you can take this forward.
Thanks, Radhika. Hi, everyone. Good evening, good afternoon. Uh, we'll quickly jump into uh, what the agenda is for today. So, we start with deep diving into why tools like Hevo exist, right? What are the challenges that exist in this space? We'll go through a bit of an overview of the capabilities within Hevo, what we offer, what we can offload from your core engineering team and your data platform team, and what kind of time and monetary savings that you can have. Then just a live walkthrough of how easy it is to create a pipeline within Hevo to move your actual end-to-end data, and a demo of one of our new enterprise-grade connectors. And next steps, we'll just walk you through a brief case study from one of our customers, and take any questions that you have about the platform or about the tool. Um, so the question is that why modern data teams need an ELT platform, right? So data integration has been around for as long as we know in some way or form, and people have been using different tools, different capabilities, building something in-house, using open source platforms to solve it here and there. There are great tools out there like us, which pretty much solve this for you, where you don't need to actually put somebody to manage your data pipelines, which is a grunt work, right? It's not something that you build once and it's going to last like this forever. Schemas evolve, data changes, data's capacity changes, and you don't even, sometimes you're not even prepared for how fast it's going to grow. So, data being at the center of each and every org, we are pretty much always going to be there. So, uh, whenever you create a data pipeline, there are going to be problems, right? There's a complete maintenance overload that sits on the data engineering team, and each and every company of certain scale is not always ready to have dedicated people to actually solve it. There is going to be upstream changes. So there could happen that one morning somebody up at the source system needed an additional field and they added it. Uh, Downstream pipelines generally tend to break, and there are break of contracts. And even in my previous experiences, orgs, friends within the data platform community have always faced this challenge. Uh, my schema changes, pipelines break, my customer is angry with me the next morning. Uh, the monitoring itself. So even if you build the pipelines in-house, building the observability layer on top of it is even harder. Uh, Understanding when the data is missing, understanding when pipeline goes down, building proper alerting on top of it, and getting to know what's actually happening with my pipeline. Having latency. So even when you build a pipeline, there is going to be problems around it scaling. Then there is capability around, let's say, you need that data in a particular stipulated time. You have a latency specific need, and whatever pipeline you build might not be able to achieve that. Then comes the retry capabilities itself. So failure handling is another complex thing. You deal with really complex data. It could fail in parsing. It could fail in reading. It could fail during loads. It can fail at each and every stage, and each and every stage could have very different restrictions, which you see for the very first time. With the collective knowledge, like a tool like us, we've pretty much seen each and every scenario. for different databases, different destinations, and we're pretty aware of what it takes to actually build a robust pipeline, uh, which pretty much you don't have to look at for weeks, right? So that's what we offer. We offer a reliable, low latency, real time data access for you. Uh, Just at a glance, we are a no-code EAT platform. We pretty much can be configured from the UI. Of course, there are extensive APIs available if you want to orchestrate it as well. It's pretty much zero maintenance. Once it's built, you can pretty much forget it exists unless we are charging you a credit card. But that's the main idea behind us. We are a platform that works like any other ISP that exists. You expect us to pretty much continuously replicate what is required. We do support 150 plus data sources. We also have CDC. We pretty much specialize in CDC. That's our primary forte. And our pricing is fairly predictable. Of all, we'll touch upon it a bit towards the end part as well. But the whole idea is that we are an event based pricing model, which makes it a lot more predictable than any other pricing model out there, which exists either on specific volume or how much a log is being processed or how many unique rows you might have. So uh, we are pretty much the number of inserts, updates, deletes that happen at your source is what you pay us for. So we'll deep dive into our new enterprise grade pipelines. We'll walk you through the capabilities, and then we'll just quickly jump into creating one and seeing it in action. These are primarily built for really high throughput use cases. They scale, they can handle pretty much thousands of objects, thousands of tables, uh, TBs of data, and doing it within actually fairly predictable timelines on both ingestion and load sides. Further, we bring in a lot of control over what you want to do with the pipeline. So, how the schema evolves, how it changes. There's significant amount of observability available upfront, which we'll see shortly. And a lot of our focus has been on how do we optimize your load costs overall. That means bringing your total cost of ownership of a data platform down. Uh, this specifically refers to what kind of compute costs happen when we load something on the warehouse or how we read from your databases, which could be auto scaling in nature. So we have specifically optimized on both these fronts significantly. How do we trigger the load? How do we optimize for the kind of queries that we run at what size, which batch size, and how do we read from your sources as well? Further, we have built observability on top of your latency as well. And we're talking about true latency, which is pretty unique to us. We monitor the actual source creation to the destination load time. So you know how far behind your actual data warehouse is from your source. So at any point of time, you and your customers are aware where the data platform is at, which is a fairly hard question to answer out of the box for a lot of ETL vendors or when you build your pipelines in house. Like you really don't know what's a true average or mean latency. We pretty much give you the max latency out of the box, and we also give you the capability to trigger alerts if we breach that latency or there is any kind of spike that happened on your source. To give you a brief journey, this is our journey of improving our throughput over a period of time. Very specific to Postgres, extends to other sources as well. But we started this venture sometime in Feb, and month over month, we are kind of uh, almost 4x from where we started, but the journey is not over as on yet. I believe our target is to actually uh, kind of double it as of now. So there is a lot more to come. And just to give a brief reference, this is the size of the data set that we were using for reference. It's not a TDP baseline data set that a lot of people use, which generally comprises of 8 tables. That is, this you can see is 2,600 objects and looks at a very small record size, which does not represent your true data, right? Generally, production use cases are fairly large. They have a large number of records, large number of tables, complex structures, complex relations, as well as long running transactions, long running queries. and even the size itself, it could be overwhelming. So taking all of this into account, we created our own benchmarking sets, which fit more closer to the customer profiles that we see today, as well as the kind that we see in the market, like more closer to your actual data rather than some generic data set that people use for benchmarking. Actually, databases, but not really, does not translate to how well the ETL performs. So we'll quickly jump into the demo at this point. Uh, I believe, sorry. So for this, we will be using Postgres first or maybe uh, as the option and Snowflake as a destination. Quickly copy this. So uh, first get to name the pipeline. So since we are doing a demo day, we will name this and Uh, basic credentials go in here. You configure the source, configure the destination. For Postgres, we specifically use PG output. So that means that you need to define the publication key within the source. I have done this beforehand, but it's fairly easy. It's just a single query. Generally, you will need admin credentials to do something like this. And that's it. You also get the option for enabling log monitoring, which is, again, unique to Hevo and our intent to be a fairly reliable and observable product where you can actually set how large your wall can grow to. And if we reach that size, we'll actually drop it. This is to prevent any harmful impact to your source systems. The intent is not to actually bring the source database down, which is possible at least in older versions of Postgres, where if the wall keep size is not actually mentioned, the database can go down. With the newer versions, it is enforced, so the war pretty much hmm, I'll say the offset will be flushed, which means that the log will be invalidated, so it will need a restart if it reaches a size, but again will not do harm to the database. You can also send let's say I'll put it at 100 GB and I can set a threshold when I should get the email at 60%, and I can also set when I should get an email or not, right? So at this point, it will send an alert, and if it reaches a threshold, that is 100 GB, it will drop it. Will not use it for now. You also get SSH, SSL as options. We'll quickly jump into the demo at this point. Uh, I believe, sorry. So for this, we will be using Postgres first or maybe uh, as the option and Snowflake as a destination. Quickly copy this. So uh, first get to name the pipeline. So since we are doing a demo day, we will name this and uh, basic credentials go in here. You configure the source, configure the destination. For Postgres, we specifically use PG output. So that means that you need to define the publication key within the source. I have done this beforehand, but it's fairly easy. It's just a single query. Generally, you will need admin credentials to do something like this. And that's it. You also get the option for enabling log monitoring, which is, again, unique to Hevo and our intent to be a fairly reliable and observable product where you can actually set how large your wall can grow to. And if we reach that size, we'll actually drop it. This is to prevent any harmful impact to your source systems. The intent is not to actually bring the source database down, which is possible at least in older versions of Postgres, where if the wall keep size is not actually mentioned, the database can go down. With the newer versions, it is enforced, so the war pretty much hmm, I'll say the offset will be flushed, which means that the log will be invalidated, so it will need a restart if it reaches a size, but again will not do harm to the database. You can also send let's say I'll put it at 100 GB and I can set a threshold when I should get the email at 60%, and I can also set when I should get an email or not, right? So at this point, it will send an alert, and if it reaches a threshold, that is 100 GB, it will drop it. Will not use it for now. You also get SSH, SSL as options, as well as having the capability to use VPC, Transit Gateway, Reverse SSH, for any of your networking needs. Um, so uh, should take a minute or so where we make the connection. Uh, oh, uh, did not expect this to happen. We'll just go with MySQL for a moment. Believe we exhausted the possible replication slots in this case. So we'll get to see any possible cases here. If the connection fails due to any reason, that is. So, yep. So that's it. Test connection was done. I'll use a pre-existing destination that I already configured, but the config is fairly simple, right? You run the required queries on your Snowflake, as well as you give the URL, the warehouse, the DB. Schema is not required as such. The authentication we support via access credentials as well as private key. In this case, since this was trial account, I just used access credentials. Again, we'll go through a test connection just to see if things line up or not. And we're done. So for next steps, you get a lot of control on what the pipeline should do in which scenario. First, how do you want to load your data? Is it merge or append? In merge, we will, of course, use the existing primary key on source and uh, use it to deduplicate on your destination. The other option is append, where everything is inserted as a new record. So in CDC, it pretty much becomes that you get each and every change in your destination if you would like it in append mode. And you can, of course, recreate the latest record. We do give op types for you to actually write complex queries to get that as well. Next comes a failure handling policy. So here you get control over what happens when there is any failure encountered within the pipeline. We have two kind of policies. One is don't load that data for that object at all. So what that means is that if there is even a single failure in a particular table due to formatting, due to any uh, out of bound record, or let's assume it was unparsable, the whole table will not have anything loaded. We'll mark the object as failed, and the job and the batch will be marked as completed with failures. In the other case, you get the option where we load it till a certain threshold. The threshold arbitrarily is here is 10K. Can certainly be changed, but what it means is that at a best effort basis, we'll continue to load till there are any records faulty up till 10,000. If we cross that threshold, then again, we'll start failing that particular object. Otherwise, everything goes in best effort basis. Further, you get the option for schema evolution control, where you see that you can have allow all changes, block all changes, or allow column level changes. So fairly standard in nature. If you want the pipeline to actually evolve as the source changes, you go for allow all. If you have the need that my source is going to be fairly dynamic, I don't want any changes to flow through, right? So the pipeline does not break at all. You block all changes. All new records will continue to flow, but let's say a new column is added, it will not get reflected in the destination table in your warehouse, but the records will continue to flow. You can always go back and re-add them, restart the object to control this. In the other case, there is column level changes. So in this case, if you add a new column in a particular table, you get to add it. Like it will get added automatically, but a new table, new schema, even though the change is detected, it is marked as skipped and of course can be added at a later date. So in this case, I'll go with allow all. And then for replication type, you get to choose, do you want to start from pretty much now? So you don't need to load your historical data. It could be because you're getting it from a different path, or it's fairly large, or you're testing things out. The other is that you want the whole historical data to load. Then you get to see set the frequency. How often do you want to load it? How do you want to do it? So let's say you can do it every 5 minutes in this case. So the pipeline will load every 5 minutes. Then you can set what is my actual latency. So I want like to know that whenever I am crossing a 8 minute threshold. So let's say I have business case where if it goes over 8 minutes, things might not be working smoothly. Maybe we are running a warehouse which really needs updates, and any loss in efficiency here could lead to potential revenue loss. So then you get to select a fairly detailed object selection page where you can see for each and every object what the fields are, what is possible to select, and how many fields are there, what is the identified primary key, which database it was part of, which particular object is there. So we'll just go towards the last page where you get to review everything and sign off on the pipeline, and then we can kind of deep dive into a couple of pipelines that I had created before this call. And that's it. So it will take a minute or so to initialize, but while that happens, we can go through a particular pipeline that we had created just before this call. So what you see here is a job history. A job is kind of a batch internally that Hevo tracks whenever we run the pipeline. This is when the pipeline was created. The first job was historical in nature. It processed about 1.85 million records in a few minutes. And in this case, you can see in a bit more detail all the stats around the jobs, how many records ingested, loaded, if there were any failures will be highlighted here. If there were any object level failures, they would have been highlighted here. 67 would have are there and 0 are failed. You can further filter them by different statuses. If they had any issues, you can sort events like by events. So the largest tables by record size, how much time did they take? You can further see a breakdown of ingestion and load as well, because there could be failures on both different stages due to different reasons, and they will be highlighted here. In a certain case, let's assume there could have been a failure, but before that, we can just observe the latency. So the latency that you see here is a max latency for the pipeline. So max latency is 5 minutes 30 seconds for all. And for a single object, like for this table, what was the maximum latency that was observed? So this gives a true sense what actually happened within the pipeline. You can further download detailed session logs, which contain uh, pretty much all the queries that we ran at source, all the queries that we ran on the destination, what all actual activities that we did during the run of the job are mentioned here. You can also see if there are failures. So it's a fairly debuggable, transparent system on what happens. Of course, there is a lot on our side where we already monitor things. If things are not working fine, we come and look and kind of try to auto heal it at our level itself. But at the same time, you have a pretty clear picture of what's happening within the pipeline. Let's assume something would have failed, right? So in another pipeline that I had created, it had completed with failures. Fairly, oh, something went out. Sorry about that. So uh, it had completed failures, but there were no failed events. So if I sorted by failures, nothing was actually failed. But if I go and kind of filter on status, I'll see that this particular object failed, and you will see a very clear description on what happened. So in this case, what had happened was there was some schema changes that I intentionally triggered while the historical was happening. In this case, it will get the schema became inconsistent, and you know that this particular object, that's table 51, did not actually load. To actually load it, we can of course come back here, re-trigger it, and sorry. So mhm. Yeah, so it became inconsistent here, as you see. Uh, to recover this, we can always resync it. You also get the option to drop and load just in case if the schema was not handleable. But since there's another job that is already running, I'll not trigger it immediately. Um, Coming to the pipeline that we just created. So I believe it has already started running. It'll take some time and getting warmed up, I believe. But it has about 1,600 objects, should take a few minutes to actually finish the ingestion to load. And we can always view all that possible data within Snowflake. That's it for the demo. Coming to how Postman used us to actually go ahead and solve uh, their data platform issues. So Postman had a unique situation where they had significant number of different sources. They were really slow in building them in-house. They were harder to maintain. They used to really get impacted by data downtime. And they were not really sure what was happening, if the data is correct or not, if the decisions that are taken are correct or not. And they were really spending a lot of time fixing all of those nuances for different connectors. So they trusted us. They started organically trying Hevo. Once they were convinced, they moved all of their workloads for various different sources. A lot of their webhooks, Stripe, uh, Redshift, Salesforce, the CRM, ads, as well as financial data and their production data to actually come through Hevo to Redshift. They use DBT integration via Hevo, where their models are kind of handled with Hevo's help itself. With this, they actually reduced significant developer intervention that went in managing the pipeline rather than to focus on what kind of data models they truly want to create, getting value for actually getting the insight rather than focusing on is my data correct or not. That is how they eventually started getting significantly more value out of their data team as a whole, where it was actually contributing to projects or deliverables that drove business decisions rather than just focusing on being that core kind of a platform itself. So with Evo, they connected significant number of sources. They were able to get to a stable state where they did not have to maintain anything at their end, but rather just go ahead and build anything on their own. So they have a fairly big catalog to which they have access to. So even if they need a new connector, they have pretty much the whole catalog present in front of them. So they can start a new connector pretty much without any development effort. From a pricing perspective, we'll quickly walk you through what Hevo offers. You pretty much get, we start at 239 per month on pricing with unlimited users, access to REST API, uh, built-in functionality like RBAC, which is required for you to maintain access control for for yourself, for your customers. Uh, all the networking and security compliances with SSH, SSL encryption, access to all connectors, and 24 by 7 email, live chat, and support. With this, I'll take a break. We'll open this up for any questions, queries, anything you would like to know about Hevo, any technical details you would like to know about the product itself. Happy to answer them.
Awesome. Thank you so much, Arav, for this quick walkthrough through the to the platform. I think you delivered the 15-minute speech that we said that you're gonna be able to connect your pipeline in 15 minutes, and I think we get to deliver that. We'll just wait for a couple of minutes, see if there are any questions, and if not, you guys can book a personalized demo with us as well, wherein we'll be able to give you like a better understanding of how your data stack can be integrated with Hevo. We'll be sending up recordings of this session as well, and we'll also be sending up couple of resources that you can have a look at in terms of what data integration checkpoints you should look at. Again, thank you, Arav. Thank you, everybody who attended, and we hope to see you soon again. Thank you.